Jai Jagannath. So, after completion of electric field and Gauss law, let us start chapter 23 of University Physics book, that is electric potential. So, you see, this is a common question every time it is asked in the board examination. That is, prove that electric field is conservative in nature, or work done by electric field is independent of path followed, or the line integral of electrostatic field between 2 points is independent of path followed. So these things we will prove now. Now see, suppose this is a point charge of magnitude plus q, and I want to take a positive test charge q naught from A point to B point along this path. So during the motion of this positive test charge, in presence of electric field of this charge, what amount of work is done, so that we will find now. Okay. Suppose the positive test charge q naught starts from A point and it is moving along this path, and finally it reaches at B point. So at A point, the position vector of A point is RA, that is position vector of A with respect to the source charge q is RA vector, and the final position vector, that is RB with respect to plus q, and the positive test charge is moving along which path? Along A to B path. So this is an arbitrary path. Okay. So now let us say at any instant that this positive test charge is reached at which point? M point. So at M point, what is the force experienced by this positive test charge in the presence of this plus q? So we know, so we can say the electric field intensity at M point due to which charge? Due to q charge is equal to, you know, what is the formula of electric field intensity? Q by 4 pi epsilon naught. Let us say at any instant the position of this M with respect to this plus q is equal to R. So this is the position of M with respect to q, or you can say this is the R distance from A. So what is the formula of electric field intensity? Q upon 4 pi epsilon naught R square. And since this is positive, this is also positive, so electric field intensity direction is away from the positive charge. So this is the direction of electric field intensity, whose value is equal to this much. Okay. So now we know when any charge particle is brought inside an electric field, it will experience a force. So now this q naught charge is in the presence of this electric field. Now this q naught will experience a force of what? F is equal to q naught E. And what is the direction of the force? Direction of the force is same as direction of electric field, because this charge q naught is the positive test charge. So now the positive charge P plus q naught will try to move along the direction of electric field with some acceleration, because force is applied, force is exerting on this q naught charge. So due to that, the charge particle q naught will try to move along this direction with some acceleration. But I want to take this plus q naught charge from A point to B point without acceleration. So without acceleration means the net force on this q naught must be 0. So then what will do? So definitely we have to apply a force in opposite to that of force experienced by q naught, so that net force on this q naught will be 0. Now see, along this direction, this q naught will experience a force of what? Q naught E, in this direction. Due to this force, the q naught will try to move along this direction with some acceleration. But I want to carry this q naught charge from A point to B point without acceleration. That means with constant velocity, so that from A point to B point there will be no change in kinetic energy. For that, I have to apply some external force in opposite to that of q naught E. So this is the external force. So this external force, what is the external force? So external force required will be opposite to that of force experienced by the electric field, that is minus Q naught E. So this external force of this value should be applied so that the Q naught charge will move without acceleration. That is, change in kinetic energy from A point to B point is equal to 0, because without acceleration means it will move at a constant speed. So if it is moving at a constant speed, change in kinetic energy is equal to 0. So now we will find what is the work done from A to B if Q naught charge is moved in the presence of electric field by the plus Q charge. Let us take at any instant the charge is at the M point, and it will move from M to N, covering what distance? DL distance. So this M, N, I am drawing in a separate figure. This is your M and N. This distance is your DL. So this Q naught charge is moving from M to N, covering DL distance, and let us say this angle is theta. So this is the angle between what? Electric field vector and displacement vector. So this angle is theta. So what I will do, I will draw a perpendicular. I will draw a perpendicular from N point to electric field. So this is a perpendicular distance. So here I am drawing a perpendicular from N point to electric field direction. So this angle is your theta. So this angle is theta. This is DL. So let us say this is our P point. So what is MP? In this triangle, in this right angle triangle, I can say cos theta is equal to what? Base by hypotenuse. So base is your MP, hypotenuse is your Mn. So that implied MP is equal to Mn. What is Mn? DL cos theta. But this MP, this is, let us say this point is MP. So this MP is along the direction of radial line. So when the particle moves, when the charge particle Q naught moves from M to N, the radial distance covered is equal to MP. So that radial distance is called dr. So along the direction of r, the change in distance is equal to dr. So dr is equal to dl cos theta. I think it is clear. So now we have to find what is the work done from M to N point. So work done from M to N point by which force? By external force. Because here electric field is doing work, and to make the velocity constant, we have to apply an external force. So the work done by the external force from when the charge particle Q naught moves from M point to N point is equal to F. We know F dot dl. So here F is nothing but minus, external force is nothing but minus Q naught E dot dl. So that is equal to minus Q naught E dot dl. E dot dl is nothing but E dl cos theta. Okay, theta is angle between electric field and dl vector. This is electric field. This is dl vector. So this angle is theta. So minus, so that is equal to minus Q naught E. What is dl cos theta? dl cos theta is nothing but dr. So this is the work done. We can say this is work done, very small work done, because it is moving very small distance. So dw. So from which point to which point? From M point to N point. But we have to find the total work done by moving this plus Q naught charge from A to B point. So total work done. So work done by external force. Work done by external force from A point to B point is equal to, I can write it is W A to B. W A to B. So this work done is nothing but integration of dW. Integration of dW. Okay. So that implied W AB is equal to integration of minus Q naught E dr. So here the so you see that is minus Q naught E. What is the value of E? E value is equal to Q divided by 4 pi epsilon naught R square into dr. So in this integration you see R is variable. So R varies from which point to which point? A point to B point. So at A point, what is the value of R? That is RA. So lower limit is RA. At final position B, what is the value of R? That is RB. That is RB. So we have to integrate this. So that implied W what done from A to B by external force is equal to minus Q naught Q by 4 pi epsilon naught. We have to integrate 1 divided by R square with respect to dr. Lower limit RA, upper limit RB. That is equal to minus Q naught Q by 4 pi epsilon naught. What is the integration of 1 by R square? Integration of 1 by R square is nothing but minus 1 by R. You know the integration. So lower limit is RA, upper limit is RB. Just put the upper limit, so minus minus plus, that is Q naught by 4 pi epsilon naught 1 by final limit minus 1 by initial limit. Now see, so we derived the work done by carrying a Q naught charge from A to B in the presence of electric field due to a source charge Q is equal to this. So we have already derived this. Now see, this value, or you can say this is a function which is similar. You see, here Q by 4 pi epsilon naught RB, here Q by 4 pi epsilon naught RA. 4 pi epsilon naught constant. Q is the source charge. So this value or this function depends upon what? R. So at B point the position vector is RB. So this is a function. You can suppose a function is fx. Let us say a function is fx. Fx is equal to kx square. So here this is a function which depends upon x. Similarly, this is a function which depends upon RB and RA. So this function is called, so here it is what? Q naught into, so this function I can say it is a function which is equal to V. That function is represented by V. Just like velocity is equal to what? ds by dt. So this velocity is a function which depends upon time. Similarly, this is a function which depends upon R. So here this function name is V, and it is called that function is called potential function. So this function is called potential at which point? B point. Minus. So this is also same function, that is potential function, which is at A position, that is called VA. Now this Q naught into VB is called, you see, this is work done. So work done is equal to this minus this. So this is work, this is also work. And that work is called potential energy. So Q naught into VB is equal to potential energy at B. Q naught into VA is potential energy at A. So that is equal to that is called potential difference between which point? B and A. So this is the work done by external force when a Q naught charge is moved from A point to B point in the presence of electric field. Okay, and we can say what is VB. So here VB is equal to Q by 4 pi epsilon naught RB. It is called electric potential at B point. So this is electric potential, just like gravitational potential, Similarly, it is electric potential at B. Similarly, VA is equal to Q by 4 pi epsilon naught RA. It is potential, electric potential at which point? A point. Okay. So now we see this is the work done by the external force. Then what is the work done by electrostatic force? So work done by the electric force or electrostatic force is just opposite to that of work done by the external force. So that is equal to, if I will say, so work done by the external force is equal to UB minus UA. So we can say work done by the electrostatic force, which is equal to minus of work done by the external force, is equal to UA minus UB. So what is UA? It is nothing but Q naught into VA minus VB. That is equal to Q naught into, what is VA? VA is equal to Q by 4 pi epsilon naught RA minus Q by 4 pi epsilon naught RB. So this is the work done by the electrostatic force. So now we see one interesting result is that work done. So you see, so work done by the electrostatic force is equal to what? Q naught by this formula. So here the work done depends upon the initial position, that is RA, and final position, that is RB. It does not depend upon on which path the Q naught charge is moving. So that means work done by electrostatic force, work done by the electrostatic force does not depend upon the path followed, on which path the charge is carried, that does not depend. So work done by electrostatic force does not depend upon the path followed, so long as the initial and final position remains fixed. So you see, suppose I will take the positive charge from A to B, like in this path. So here also work done will be same. That means work done depends upon initial position and final position. So that is why the electrostatic force. So electrostatic force is called conservative force. Or you can say electric field is conservative in nature. So in this way we proved the above equation. So just like suppose this is a body. This body is in ground. I want to raise this body from A point to B point vertically. And what is the distance, vertical height? Let us say h. So when I will take this body of mass m to this height h, then what is the work done? So work done is equal to mgh. But I will take this body from A to C, and then the vertical height remains same. So in this case, suppose this is path 1, this is path 2. So work done in the path 1 is equal to mgh, and work done if the body is taken from A point to C point along this path number 2, the again work done will be mgh. So that means work done does not depend upon the path followed in presence of gravitational field. So gravitational field is also conservative in nature. Gravitational field is conservative in nature. So you know, in the mechanics, these things we have discussed. So similarly, the electrostatic force or electric field is conservative in nature. Now see, whatever we derive, you see, So it is work done by the external force is equal to, so whatever work is done against any force, so that amount of work done will be stored in the form of potential energy. So when the external force is doing work by carrying a q naught charge from A point to B point, so the total work done will be stored in the form of potential energy. So that things you know. Suppose you see this is the pen. So this pen is in the ground. I have to raise this pen to certain height. What will happen? So when I am raising this pen to certain height, I am doing work against the gravitational force. So what amount of the work will be done? So that work will be stored in the form of potential energy. Similarly, we are doing the work done against which force? Electrostatic force. So that total amount of work done will be stored in the form of potential energy. Next, you see, suppose I will take, you see, suppose this is A point, this is B point. I am taking a q naught charge. I am taking a q naught charge from A point to B point. So here, what is the work done? What is the work done? So work done is nothing but this formula, which can be written as q naught into VB minus VA, or you can say this is UB minus UA. Similarly, if I will take that q naught charge from B point to A point, I will take q naught from B point to again A point. So what is the work done? WB to A is equal to same q naught into final position, final potential, that is initial potential. So here A is final, B is initial. So that is equal to UA minus UB. Then what is the work done? If I will take q naught charge from A to B, again B to A. So that is work done from A to B and B to A is equal to the WA to B plus WB to A. So that implied UB minus UA plus UA minus UB, just add this, you will get 0. So what is the conclusion? Conclusion is that the work done in carrying a charge from carrying a charge over a closed loop is equal to 0. So this is also special characteristic of conservative force. So in the conservative force case, the work done in a closed loop is always 0. So which proves electrostatic force. Electrostatic force is conservative force or conservative in nature. So now, this is about the derivation, or it is the proof that the electrostatic force is conservative in nature. We have proved. Now you see, work done by carrying q naught charge is equal to this. Then what is work done per unit test charge? So we can write the work done from A to B by carrying unit charge. For q naught charge, work done is equal to this. For unit charge, what is the work done? So WB by q naught. So which is equal to, again, just divide q naught everywhere. So you will get what? Minus A to B E dot dl. That is equal to, here you divide q naught. Q by 4 pi epsilon naught RB minus Q by 4 pi epsilon naught RA, which is equal to VB minus VA. So this is the main formula you have to remember, and from this formula we can define what is VB. VB is potentiality B. What is VA? It is potentiality A. So VB minus VA is equal to what? potential difference between B point and A point. So now from this formula, we can define the definition of potential difference. Now see, from this, so you have to remember always this formula. From this formula, we can define the potential difference. Now see, so first definition, what is potential difference? Potential difference is the quantity which determines the flow of charge. Just like you see, suppose you will take a water tank. Suppose this is the water tank. Okay, there is. So if you will open this tank here, what will happen? Water will come out. So this water is coming out due to what? Due to the level difference between water. So level difference creates the flow of water. Just like you see, suppose this is one container, this is another container. So here the head of water is more, here head of the water is less. So if you connect a pipe through this, okay, so what will happen? Water will come out from the water at a high head to water at low head. So that means the head difference will create the flow of water. Just like if you will take two bodies, body A and body B. So this body A is at a higher temperature than this body at B. So here temperature of A is greater than temperature of B. So what will happen? The heat energy will flow from higher temperature body to lower temperature body. That means temperature difference creates the flow of heat energy. The head difference creates the flow of water. Similarly, suppose this is a rich person, this is a poor person. So if they have made contact with each other, if they have friendship, what will happen? The money will flow from rich person to poor person. That means if there is some difference, then the quantity will flow. Similarly, if there is a potential difference between 2 points, then what will happen? The charge will flow. Okay, the charge will flow. Second definition. Potential difference between 2 points is equal to negative line integral of electrostatic field from one point to another. Now see. So what is potential difference? VB minus VA. It is the potential difference between B and A is equal to what? This formula. So here potential difference between B and A is equal to negative, this is negative line dl, line integral of electric field from one point to another. So we can say the potential difference between 2 points is equal to negative line integral of electric field from one point to another. So that is the second definition. Third definition is the important definition. Same definition, in different way we are defining the potential difference. You see, VB minus VA is nothing but WAB by Q naught. That means if Q naught charge is moved from A point to B point, work done will be WAB. Then for unit charge, work done will be WAB by Q naught. So this WAB by Q naught is equal to VB minus VA. So that means potential difference between B and A is equal to amount of work done by carrying a unit positive test charge from one point to another. So that is the definition of the potential difference. So now we will find what is the unit of potential difference. Unit of potential difference. You see, what is unit of potential difference? What is VB minus VA? VB minus VA is nothing but WAB by Q naught. So what is the unit of work done? Work done unit is joule in SI system. What is the unit of charge? Coulomb. So this joule per coulomb is called volt. This joule per coulomb is called volt. So this is the unit of potential difference. So we can say if the amount of work done is equal to 1 joule by carrying a 1 coulomb charge from one point to another, then the potential difference between that 2 points is equal to 1 volt. So you can define in this way. So this is the potential difference. Now question comes, potential difference is vector quantity or scalar quantity? Definitely potential difference is the work done per unit charge. It is work. So work means it is a scalar quantity. So potential difference is a scalar quantity. Then what is the dimensional formula? What is the dimensional formula of potential difference? It is W by Q. W, what the dimensional formula? ml square t minus 2. Charge is equal to IT. I is ampere, time is t. So if you will calculate, you will get m L square t minus 3 a minus 1. So this is the dimensional formula of potential. Now, now we'll start concept of potential. What is the, so we have discussed potential difference. Then how can you find the potential at any point? That is concept of potential. Now see, if I'll take a unit positive test charge from A point to B point, then the work done is equal to this formula. So this is we have already discussed. Now, if this A point tends to infinite, so A is far away from this Q charge. So if A tends to infinity, so what will happen? So RA, this RA tends to infinite. If RA tends to infinite, then what is Q by 4 pi epsilon naught RA? Q by 4 pi epsilon naught RA, which is equal to VA is equal to 0. So in this case, I can write this formula can be written as, this line can be written as W work done from A to B. So A is at which point? Infinite point. So work done by taking a unit positive test charge from infinity to B point is equal to negative line integral of electric field from A to B. So A is at infinite to B point is equal to Q divided by 4 pi epsilon naught RB. So this is 0 is equal to VB. So that means the potential at B point, if you define, so definition of potential. Definition of potential. So how will you define? Definition of potential. You see, so there are three ways to define the potential at any point. Now concept of potential. So we have already discussed. Now definition of potential. So from this line we can define, you see, potential at B. How will you define potential at B? It is the potential is the quantity which determines the flow of charge. You see, if I will keep the initial point at infinity and I will bring this unit positive test charge from infinity to B point, so whatever work is done, that is called potential at B point. Or we can say if there is a potential, then charge can flow. So potential is the quantity which determines the flow of charge. Without potential, the charge cannot move. So that is first definition. Second definition, potential at B is equal to this formula. So from this we can define the potential at B. So what is potential at B? Potential at B is equal to negative minus negative line integral of electrostatic field from infinity to that point. So this is the definition given. Similarly, we can say potential at B is equal to this value. So what is potential at B? It is the amount of work done by carrying a unit positive test charge from infinity to that point. So this is the definition. Third definition is according to this. So we can say, so you know what is the unit of potential difference? Volt. So what is the unit of potential? Potential, that is also volt. Volt is equal to what? Work is joule divided by charge. Charge is coulomb. So 1 volt is equal to 1 joule per 1 coulomb. So sometimes question may come. So define 1 volt. So 1 volt is equal to, if 1 joule amount of work is done by carrying a 1 coulomb charge from infinity to any point, then potential at that point is called 1 volt. So 1 volt is equal to 1 joule per 1 coulomb. So this is about the concept of potential difference. Then I gave the concept of, now see, last concept is that suppose this is a, suppose you see, there is a charge, positive charge. Okay. So I want to take a unit positive charge from A point to B point, and A is at YA height and B is at YB height from Q charge. So if I'll take a unit positive test charge, that is Q naught is equal to 1 from A point to B point, so work done by the external force from A to B per unit charge is equal to what? Final potential minus initial potential. So here VB is equal to what? VB is equal to Q by 4 pi epsilon naught YB minus VA is equal to Q by 4 pi epsilon naught YA. Since YB is greater than YA, so I can say VB is less than VA. So that means VB is less than VA means potential at B is less than potential at A. So what is the direction of electric field? This is positive charge. So electric field direction is upward. So along the direction of the electric field, potential drops because at A potential is more, at B potential is less. So potential drops along the direction of electric field, and vice versa. The potential increases opposite to that of electric field. So this is important concept you have to remember. Now we take suppose there are 2 points A and B and they are very close to each other. Let us say this is DL and I want to take a unit positive test charge from A point to B point. So here work done is from A to B by taking a unit positive charge is nothing but what? Minus E dot dl and integration from A to B. So here since A and B are very close to each other, so there is no need to take the integration. So that minus E dot dl is nothing but VB minus VA. VB minus VA. So this VB and VA difference is very small because A and B are very close to each other. So that potential difference is called dV. So we can write dV is equal to minus. You see the electric field, let us say electric field direction is this, dl direction is this. So E dot dl is equal to E dl cos 0. Here you can put also. So E is along this direction, dl is along this direction. So the change in potential difference is minus E dl, or you can say E is equal to minus dV by dl. So this is called you can define the electric field like this. So electric field is equal to negative negative dV by dl. dV by dl is equal to what? Potential gradient. That means with respect to dl distance, if the potential difference is dV, for unit distance, the potential difference would be dV by dl. So this dV by dl is called potential gradient, and there is a negative sign. So we can say electric field is negative potential gradient. This is also another definition of electric field. Electric field is called negative potential gradient. Then what is the unit of electric field? Intensity. We know it is force per unit charge, that is Newton per Coulomb. This is one unit. Another unit I had told during Gauss law, you see, E is equal to minus dV by dl. dV is what? Potential difference, that is volt. Distance is meter. So this is the unit of electric field intensity. So with this, today I am concluding this class. So take care. Okay, bye.